Hello class, welcome to this video on 5.2 review for probability and statistics. So let's go ahead and get started. So we got the problem set 1. Problem set number 1 is testing sample space and probability. So four-sided die is a pyramid whose four faces are labeled with the numbers 1, 2, 3, and 4. Imagine rolling two fair four-sided dice and recording the number along the base of each pyramid. Give a probability model for this chance process. Okay, so you're rolling two dice that are four-sided, so 1 through 4. So what are the possible options for my sample space? Again, so for part A, you need the probability model, which means the sample space plus the probability. All right, so sample space. Well, we can have the numbers 1, 1. Then we can have a 1 and a 2 when we roll the two dice. We can have a 1 and a 3. We can have a 1 and a 4. We can have a 2 and a 1. Two twos, 2 and a 3, 2 and a 4. We can also have a 3 on the first die and a 1 on the second. 3, 2, 3, 3, 3, 4. And then finally we got one more row, 4, 1, 4, 2, 4, 3, and 4, 4. Okay, so there you go. We got our sample space. And then we need the probability, right? So the probability. So the probability for each of these is 1 over 16. So it's 1/16 for each outcome. All right, that takes care of part A. Now for part B, it says we want a sum of 5. And so a sum of 5, we need to, so that's 4 plus 1, 3 plus 2, 2 plus 3, and 1 plus 4. That gives me a sum of 5 when I add them. So that's 4 numbers. So the probability that the sum is 5 is equal to 4 out of 16, right? Which is the same thing as 1/4. Make sure you reduce your fractions or convert them to decimals. All right, that's it. So number 2, almost everyone has played rock, paper, scissors at some point. And so they kind of go and explain what rock, papers, and scissors are. If both players choose the same object, then it's a tie. And then so there's different options here for rock, paper, scissors. Okay, so if we're going to do a probability model, let's do the sample space. So first off, we can have the first player chooses rock, the second player chooses rock, the first player chooses rock, the second player chooses paper, and then you can have rock, scissors. Then you can have the first player choosing scissors, the second one choosing rock. We got scissors, paper. We got scissors, scissors. We got the first player choosing paper, and then rock for the second, paper, paper, and then finally paper, scissors. So that's my sample set, my sample space rather, and it's a probability of 1/9 each. Okay, so it's 1/9 because we got 9 possibilities, and each of them are equally likely. Part B, find the probability that player 1 wins the game. So player 1 wins the game if, we know that rock beats scissors, right? So if we got rock beats scissors, we have we know that paper beats scissors beats paper, right? And we know that paper beats rock. So that's 3 possibilities. So we got 3 out of 9, which is 1/3. Okay, so the probability that player 1 wins the game is 1/3, 1 out of 3. All right, so let's look at number 3. So imagine tossing a coin 4 times. That should say 4, not 3. All right, so imagine tossing a coin 4 times. Give a probability model. So we got our sample space. There are 16 possibilities here, okay? We're gonna list them all out. We can do 4 heads. Then we can do, now we're gonna do 1 tails. So we got three heads, 1 tail. Then we're gonna move the tails around. We're gonna move the T around. We got T, and and H's. So that's all one tails. And now we need two tails. So I'm going to introduce the two tails here. Oops. And I'm going to remove the two tails throughout. Okay. So we can do H, T, H, T. We can do T, H, H, T. We can do H, T, T, H, right? All that stuff. We can do T, T, H, H, right? We can also do TH, TH, which I don't think I have. TH, TH. All right, and then we can go ahead and do with three tails. So we got H, T, T, T. This is easy. This is like think of it as we're just moving one heads around. So we get T, H, T, 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 H, T, 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 H, and then finally we have four tails. So that's 2, 4, 6, 8, 10, 12, 14, and 16 possibilities. All right, and so the probability of each is 1 out of 16. All right, so part B. What is the probability of event B, which is getting heads twice? All right, so we want to get exactly 2 times. So that's getting heads twice. So that means this right here. 1, 2, 3, 4, 5, 6, and that's it. That's 6, right? So it's 6 out of 16. So divide by 2. Or divide by 2. And we get 3 over 8. So 3/8. Okay, and that answers part B. Okay, so that's number 3, part B. Now let's look at the next problem set. So this problem set is about valid probability models and using the addition rule. Okay, so in government data, a household consists of all occupants of a dwelling unit. Choose an American household at random and count the number of people it contains. Here's the assignment of the probabilities. So we got the probabilities here. The probability of finding 3 people in a household is the same as the probability of finding 4 people. Okay, so let's just call this X, I guess, if you will. So they're the same, so we'll call them X. What probability should replace the question mark? Remember, the probabilities need to add to 1, right? So we're going to add the probabilities and they should add up to 1. So the sum of the probabilities is equal to 1. So let's add them up. So we got 0.25 plus 0.32 plus 2x, right? X plus x plus 0.07 plus 0.03 plus 0.01, and they should equal 1. So we get 1 is equal to 2x plus, and then we can just add those numbers. So 0.25 plus 0.32 plus 0.07 plus 0.03 plus 0.01. So we get 0.68. All right, we got minus 0.68 on both sides. All right, so we got 2x is equal to 0.32 divided by 2 on both sides. So you got x is equal to 0.16. Okay, so that's part A. Part B, find the probability that the chosen household contains more than 1 person. So the probability that x is bigger than 1. If it's more than 1 person, that means you're looking at 2, 3, 4, 5, 6, or 7 people, right? So the opposite of that is just do it for 1 person, right? So just do it for 1 person and then subtract that value from 1. That's called the complement rule, okay? So you can add all these numbers, but the easiest thing to do is just take 0.25 and subtract that from 1. Okay, so we're going to do 1 minus the probability of the opposite or the complement. So now we want it to be less than or equal to 1. But we know that there's only one number that is less than or equal to 1 here. It's 1. All right, so we're going to do 1 minus 0.25, which is 0.75. That's one way to do it. Again, the other way to do it is just to add the values for 2, 3, 4, 5, 6, 7, and then add the probabilities. All right, so number 2, the National Household Travel Survey gathers data on the time of day when people begin a trip on their car or other vehicle. Choose a trip at random and record the time at which the trip started. So here are the probabilities for each outcome. Again, we're trying to find the question mark. So let's do that. So the sum of the probabilities need to equal to 1, right? So let's add these up. 0.023, 0.019, 0.166, 0.254, 0.221, x, and 0.098. So again, we're just adding the probabilities, right? And then it should equal to 1. And so that's my equation, okay? So we're going to add these all up. So let's see what we get when we add them up. Okay, so if I add those probabilities, I get 0.781. So I get 0.781 plus x equals 1. Subtract 0.781 on both sides to get x, okay? So x is 0.219. All right, so now we know what that is. All right, and then, so there's your guy, and then part B. Find the probability that the chosen trip did not begin between 9 and 12:59 p.m. Okay, so this is 9 and 12:59 p.m. We want it did not, okay? So let's call this event A, okay? So the probability of not A, this means not A, is equal to 1 minus the probability of A. So if it's a 25% chance that it's a 25 or 0.254 chance that it's between 9 a.m. and 12:59 p.m., then you just have to subtract that from 1, right? It's about a 75% chance that it does not occur, right? So you just subtract it from 1. 1 minus 0.254. So in this case is going to be 0.746 chance. So almost 75%. All right, the other way that you could do that is just add these numbers to get the same result, okay? All right, so problem set number 3. So all human blood can be typed as one of blood O type A, B, or AB blood type. But the distribution of the types varies by race, okay? Here's the distribution of blood types of they should say Black Americans for this particular problem, but it doesn't really matter. Let's just say that this is the distribution of blood types of Americans. Here is talking about race, so they had specific ones. But yeah, let's just say we have this as a blood type, and we need to figure out what the blood type is for AB. All right. So let's say Rolanda has type B blood. She can safely receive blood transfusions from people with blood types O and B. Find the probability that she can donate blood, that a randomly chosen American can donate blood to Rolanda. So it's the probability of O blood or B blood. Okay, so that means you just got to add the probability of O blood plus the probability of B blood. You just got to combine those. That's it. So 0.49 plus 0.27, so it's going to be 0.76. That's it. That's all there is to it. And what's the probability that a randomly person cannot donate blood to Rolanda? So that means it's not that. So not O or B. So not means it's the opposite, the complement. So you do 1 minus that, and that gives you your answer. It's got to be 0.24. Okay, so basically you just got to add. I didn't even realize that they didn't give you that. So But we can easily find that because they had to add up to, the probabilities had to add up to 1. However, you don't really need that. You don't really need the question mark to answer the question, to answer this particular question. So 0.76. Oh, I added the wrong ones here. Sorry about that, guys. So here they want O blood or B. So I added the wrong ones. My bad. So 0.49 plus 0.20. I just realized that number was a bit off. So it's 0.69. Okay. And then you can just do 1 minus 0.69. And that will give you 0.31. All right. Okay, and that's it for that one. All right, so let's look at number 2. Canada has 2 official languages, English and French. Choose a Canadian at random and ask, what is your first language? Here's the distribution of responses. All right, so describe how you would design a simulation to help answer this question. Or, oh, this is a typo. That shouldn't say that. I'm sorry. This is a typo from the first one, from the first review. So let's look at this one. Find the probability that the chosen Canadian's first language is English or French. Okay, so it's pretty straightforward. So you just gotta, you wanna do probability of English or French. So you just gotta add them up. So 0.58 plus 0.21 equals 0.79. All right, and then part B, find the probability that it's neither French nor, neither English nor French. So the probability of not E or F, right? That just means to do 1 minus the probability. So it's going to be 0.21. That's it. You just literally subtract from 1. You don't really need to find this other. You just simply use the complement rule. All right. If you want to find the other and then add those two together, you can, but that's not necessary. All right. All right, guys. That's going to do it for the video. I hope you found this useful and informative as usual. I'll see you in the next one.